All right, so we're going to take a look at the assessment from today, the mastery check-in that we tried to do when it comes to the multiplication work that we're doing. I'm going to go through each problem. You can see how you did. I gave you your copy back. I had copied it. So I want you to not redo your work, but write about what your mistake in your process was, or the mistake in your thinking was. Like, what great error did you make if you made an error, or let me know that you got everything right. Okay, so that's your job today. Your job is to go along with your test, look to see if you did it well, and try and understand what your mistake was. What was your error? If you made one, again, awesome that you did, and try to think about what you don't know, and then make a plan as to how you're going to learn that. Because again, we're going to be starting fractions soon, so there will be we'll be revisiting this from time to time. But what might you be able to do to support your learning? So let's go over this. Teresa was absent from school yesterday, so she asked her table partner Jaime to help her solve the problem 6,789 times 7 using the standard algorithm. Jaime created the following example to show her. Was Jaime correct? If no, explain where she went wrong. Oh, Jamie. Or what she was missing using words and numbers. Be as clear as possible to help her out. And then solve the problem the correct way, showing all of your work and using math vocabulary. So let me see if if Jamie is right here. 7 times 9 is 63. Here's the 3, here's the 6. 7 times 8 is 56. Plus 6 is 62. Oh, 7 times 8 is 56. 7 times 7 is 50. No, 59. Well, I'm not sure what the problem. I know that Jamie's not adding these numbers up here. She's letting them go, so this is not going to be the correct answer. If I do a quick rounding and a quick thought process here for an estimation, 7,000 would be around 49,000. That would be my estimate. I mean, that's around 49,000. If it was 6,000, oh, I could even make it better. So if I rounded up to 7,000, that would be 49,000. If I rounded down to 6,000, that would be 42,000. Halfway in between, which would be 6,500, would be, let's see, that's 7, half of that is 3.5, so 45,500. So it should be above 45,500 because 45,500 is 6,500, and our answer is, or the factor we're starting with is above that. And so if I look at this, it is above, no, it isn't even above 45,500. So I know this answer is wrong, so I know what she did. But she wasn't adding up here. She did not add the, what do I want to call that? The groups of 10 and 100, tens and hundreds that she carried. Okay, and if I'm going to redo the problem here, I have 6,789 times 7. 7 times 9 is 63. Carry the 6. 7 times 8 is 56. Plus 6 is 62. Carry the 6. 7 times 9 is 49. Plus 6. Oh, if I put 1, that's 50. Another 5 would be 55. 7 times 6 is 42. Plus 5 is 47. So 47,523. That is above my 45,500. I feel pretty good about it. I'm going to move on. All right, same thing here. Below. Let's make sure I get this up on the camera. All right, Jessica solved the problem 6,038 by 5 by using the standard algorithm. She showed her work and solved the problem below. So same sort of thing. Was she right or not? It looks like she was around, right? 30,000. So let's see. 8 times 5 is 40. Oh, 40. Well, what happened? 40. She put a 0 up there. Oh, she wrote like the 4 for 40 and then the 0 above. Oh, interesting mistake. 5 times 3 is 15. 1. 5 times 2. Oh, so that was the only mistake she made. I wonder why she made that mistake. That's interesting. So the mistake she made was her first calculation. She wrote the 4 from 40 which is a 10. In the ones column. Oops. So that was her error. Solve the problem. 6,038 times 5. 8 times 5 is 40. 5 times 3 is 15, plus 4 is 19. 5 times 0 is 0 and 1, and then 5 times 6 is 30. So 30,190. I can check that if I wanted to in my head. I know that 5 times 6,000 is 30,000. 5 times 30 is 150. And 5 times 8 is 40. And I know 150 plus 40 is 190. So that all makes sense. Oops. All right, this one, a lot of you really thought this, I think you went over and above what the thinking was required here. Use the following numbers to label the array and write an equation. 25 by 112 equals 2,800. So I would want to label the right area. So this side is 25, this side is 112, and inside is 2,800. That's all you had to do there. And then write the equation. Okay, Joaquin was trying to solve 125 times 34. He decided to use the area model to solve the problem. Here's how he set up his problem. After he sets the problem up, he asks you for feedback. What would you tell him? So I see he separated the problem, 125, 34. I see a line here and a line here. Oh, I don't see a line here. He hasn't split up this area. What I would tell him is that because he has, it's 3 digits by 2 digits, he needs 6 rectangles. Because he's going to do 6 calculations. He's going to do 4 times 5, 4 times 20, 4 times 100, 30 times 5, 30 times 20, 30 times 100. So he needs 6 rectangles, and right now I only see 1, 2, 3, 4. If we add another line all the way through, that's 1, 2, 3, 4, 5, 6. That'll give us our 6 calculations. So my feedback would to add a line in between 120 so that you have 6 rectangles, because 3-digit number by 2-digit number results in 6 calculations. Well, 6 multiplication. 6 multiplication calculations. Okay, cool. Moving on. Solve using the standard algorithm. 824 times 35. Let's see. Let's just go. Actually, I should do a estimation, right? First. Let's see. 800 times 40. 800 times 40 is the same thing as 1,600. Oh, sorry. What am I doing? 800. 800 times 40. So if I look at this as 800 times 40, that would be the same as 1,600 times 20, which would be the same as 3,200 times 10. So my estimation should be somewhere around 32,000. You know what? I'm just going to estimate here too. This can be round up to 100, so that one's going to be pretty straightforward. 100 times 77 is 77,000. So let's rock and roll, see what we can do. 4 times 5 is 20. Carry that 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 times 8 is 40. Plus 1 is 41. Another thing I like to do is kind of cross these out so I know I used them already. Now, remember this is 30 times 4, so I need to respect that and have that 0 there. Is 12, well, 120. Carry that 1. 3 times 6, 2 is 6, plus 1 is 7. And then 3 times 8 is 24. I'm going to add all these together. 0, 4, 8, 8, 2, which is 28,840, which is around 32,000, so I'm feeling pretty good. Pretty good about myself. I might have to use a calculator to really check, so let me do that right now. Let's see. So 824 times 35. equals 28,840. Okay, good. I got it right. Now onto this one, 973 times 77. Real quick, think to yourself, is my estimation here going to be closer to the actual answer than this one? Or is it going to be further away? And I'll tell you. So do that right now. Do you think this estimation, 77,000, is going to be closer to this correct answer? Or do you think 32,000 is closer to the 28,000 over here? All right, so let's do this work. 7 times 3 is 21. 7 times 7 is 49, plus 2 is 51. I'm going to cross out that 2. 7 times 9 is 63, plus 5 is 68. And I use that 5. And remember, it's 70 times 3, so I need to drop down that 0. 7 times 3 is 21. 7 times 7 is 49 plus 1, which is 51. And 7 times 9 is 63 plus 8. Hey, look at that. It's the same thing, 6811. That makes sense because I'm using the same digits to multiply. We're going to add 1, 2, 9, 14, 7. 74,921, which was close to my 77,000. And which one was closer? It looks like this one was closer, doesn't it? That was... Well, now you'd have to start thinking about percentages and stuff, maybe, to really think about closeness. So we're not going to get into that too much. Let me use the calculator real quick to make sure I'm right. 973 times 77 equals... Oh, what happened? 973 times 77 equals 74,921. Okay, cool. Now see, you saw I made a mistake with the calculator. It's really important, but my mistake, it was what, 100,000 something? So it's really important. I had that estimation, right? So even using a calculator, we can make mistakes. But if you don't have an estimation in mind, you're just going to write that answer down without even thinking. So estimating is just crucial. If you're not doing it, do it. All right, match the following equations with the correct array, area, model, etc. 4 times 9 equals 36. Well, that's certainly not it. What's this one? 1, 2, 3, 4, 5, 6. No. So this is a 6 by something. This is 44, 33. This looks like division. What's this? 4, 1, 2, 3, 4, 5, 6. 9 groups of 4. So that's 36. So that's E. Oops. That's certainly not an E. All right, 37 times 12. I know that's none of this. Okay, here's 30 and 7, 10 and 12. 370, 430, 444. That looks right. That's A. 30 divided by 5 equals 6. That's kind of this area I thought we have. Right? 1, 2, 3, 4, 5 groups of 6, which is 30. And then we're dividing that by 5, right? 5 rows, and inside one of those rows is 6. So that would be D. 44 times 33, so I'm going to guess that's this one here. See 44 and 33. And then 6 by 7, which was this array right there. Okay. So take a moment. You should know how you did at this point by looking at your work compared to mine. Again, what were the mistakes that you made, if you made any? Okay. Again, I have a copy of your assessment. Okay, so let me know what you think your mistakes were. What is your plan moving forward to address those mistakes in this learning? Okay, and maybe think about what you think was your best mistake or coolest mistake if you made one on your assessment, and we'll maybe have a coolest mistake of the week. Okay, thanks for checking it out, and I'll see you later.